This is Action Lab. He does a lot of tests with vacuum chambers. Here he has a little water balloon filled with helium to show it drop under a vacuum. Okay, I want to point out a couple things. One, I don't know if you can see it yet, but he had to add a piece of duct tape to the top of it because it probably didn't want to fall. But number two, he's tried this with other balloons and they just expanded until they popped. The little water balloons are the only ones tough enough to compress the helium enough to get them to drop. And when it drops, it trickles down. It barely drops. Now, we're told that gravity pulls mass down 9.8 meters per second per second. So under a vacuum, or at least a full vacuum or close to it, this thing should fall the same speed as a lead ball. Now, that's a nail in the coffin because it barely trickles down. Okay? And there's no wind to hold it. So even if he's not at a perfect vacuum, there's barely any air in there at all to hold it up. So how much more is there to take out to get it to start racing down like a lead ball? Not enough. Okay, and this is so if this balloon was elastic enough, it would expand. If it was stretchy enough, it would keep expanding until it filled the whole container if he kept pulling the vacuum. Gas does not go down. It's not heavier. The gas in that balloon is not heavier at the bottom. That is horseshit. Gas fills the available space, period. So give it a look. Point being here is it's supposed to fall at the same rate as a lead ball if there's no air resistance. One other thing I want to point out real quick. There's a cut in here. So this thing stretches out a little bit, but then it quits stretching. And at that point, he does a time cut. It's not nothing deceitful. Just to save time, he does a little cut in there, and because he's still got a ways to go before it falls. But the balloon doesn't keep growing. So that's showing me that it's compressing the helium in there. Now, the point there is that if you take helium and you put it in a tank, it will lighten the tank a little bit until you start compressing it. If it's just free to move and relative to the pressure outside the tank, it'll have a little bit of a buoyant effect. But once you start compressing it, you're changing the relative density of it, and you're making it denser, so the tank's going to get heavier. And so what would be different with balloons? If you can get a strong enough balloon like he has done, then it compresses it just enough to get it to trickle down, not fall like a lead ball. So the notion of gravity, mass attracting mass, is out the door. So that's what I want the trolls to respond to here in this video. Don't respond to nothing else. Respond why this balloon, when it does fall, when he gets to a full vacuum, why doesn't it fall at the same rate as a lead ball or a golf ball or something? It's supposed to. Is there enough air molecules left in there under his what he calls a full vacuum, 0 atmospheres, to hold it up where it trickles down? And why did he have to add the duct tape to the top of it anyway? Point being is that even if the helium was, even if the vacuum wasn't lighter than the helium, that still follows the rules of relative density. The vacuum is less dense than the helium, so I could argue the helium would drop anyway. But it seems to give problems where they have to add tape, and then when it does fall, it just barely trickles down, and they have to use tough balloons that'll compress the gas. So the more of a vacuum he pulls, the tighter that balloon's getting, the more he's compressing the helium in there. So give it a look. Do you see that little cut there? Do you see that cut? So there, it just trickled down. It trickled down under full vacuum. And now you can see the duct tape on the top. So this is a nail in the coffin for mass attracting mass. There's no gas at the bottom of any chamber, not a vacuum chamber. The gas expands in every direction. Okay, this is clear proof of that. I mean, if people don't just want to ignore what they're seeing or try and think of ways around it. I sure would like to hear it. This video is going to be about mass falling at 9.8 meters per second in a vacuum. Okay, they say that wind resistance is the only thing that changes the rates that mass falls. Without the wind resistance, the feather and the bowling ball fall at the same rate. Okay, this particular video, and this ain't what the whole video is about, so you definitely want to watch to the end. This is a Brian Cox video at the vacuum chamber in Sandusky, Ohio, the NASA vacuum chamber. Well, I know this video has been picked apart, namely because there's no single take from beginning to end of them dropping it, which raises red flags right out of the gate. Why would they not just show it dropping from top to bottom? Because they don't fall at the same rate. That's why. Not even in a vacuum. And I'm going to prove that. And then I'm going to demolish it. The notion in general. But, why would they even try something like this? Watch this. You see right here, the feather is just a little bit above the top of the bowling ball. But the wire, the top of the wire that you see above the bowling ball is higher than the feather. So I was about to make a little longer of a video. I don't even have to. Just this says it all right here. I'm going to play this in slow motion and just watch. Hey, you seen there the bowling ball taking off faster than the feather. Watch again. Now see where I stopped it? I stopped it with just a little bit of the wire on top of the bowling ball. See right next to the feather, you see that little bit of wire at the bottom of your screen. Now you see the feather, like a giant portion of the feather above the wire. Much less the bowling ball. It's above the wire itself. Watch it on down. See, so there's a cut. There's a cut. And right there you see the bowling ball higher than the feathers. But we'll chalk that up to perspective. But just now, even with perspective, you see the top of the bowling ball is right level with the top of the feathers, if not a little bit higher. So that to me is a couple different takes already. See, so what they did, they dropped it down on wires until it got about 5 foot off the ground, and then they do a take and drop them. If you drop a feather and a bowling ball from about 4 or 5 foot, they're going to fall pretty close to the same rate. So all they had to do is drop it down and then do another take of them dropping it from about 4 or 5 foot where you can't see the top of the screen, just like they have right here. Once again, the wire is well above the feathers. In fact, that looks like a different height. That's right in the middle of the middle and the top. But I'll show you one more time, but I think it's pretty crystal clear. You see the wire is obviously above the feathers. Now, one more time, just to show y'all, the bowling ball clearly takes off faster than the feather, and the wire is clearly higher than the top of the feather at this point and lower at the end. Proof is in the pudding, people.